Hey, so the protein that I got was the alpha epitheliosodium channel, or alpha ENac. Well, its mutation is the cytosine right here is being replaced with arginine. This causes Little syndrome, and it is a genetically inherited high blood pressure. And okay, so like if you just have hypertension, it shows up when you have hypertension, suppressed renin and aldosterone, the hormones, and then active ENac. The function of the protein is a rate limiting step for sodium ions, which allows reabsorption across the tissues, the membrane. And I said it was a hormonal protein because of its regulation of the sodium ions. The location of this will be in the apical membrane of epithelial cells. And those are, the membrane is like at the end of a tubule, and the epithelial cells are cells that are like close to the surface. So like your skin, organs, and blood vessels. These could be, it's typically in the kidneys, but it could also be in the lungs and colon and other organs. And this is in animals. This pertains with the mutation, it becomes more active because it has to do more work to push out those sodium ions and stop it from entering back in, because it's just clogging it and it's making everything very acidic. That's why you would have hypertension and your blood pressure would be high. So on the original side, the cysteine has functional groups, carboxyl, amine groups, and sulfhydryl. It's hydrophobic and polar, but the polarity comes from the sulfhydryl groups, and it's very mild, so it allows the original to be hydrophobic. And this side is smaller than after the mutation. Since it is hydrophobic, it doesn't bond with water, but the sulfhydryl groups bond with other amino acids and proteins to form disulfide bonds. Now in the mutated side, the functional groups are carboxyl and amine. It's hydrophilic and positively charged. This side is larger than the original because it works more. Since it is, this side can pair with amino acids and proteins to create hydrogen bonds, which is different from the original because it was hydrophobic and was not able to make those hydrogen bonds. So this protein allows for cells to regulate the sodium throughout the body so that it can work. With the mutation, it is able to do that. It helps regulate the sodium ion so that you can normalize your blood pressure. Yeah. And the cell will be like the kidney. It'll be able to work functionally because it isn't filled with salts from the sodium. my model limitations was I don't actually show the sodium ions going through and how like the sodium buildup can affect it, or like the extra tubulars where the sodium ions will come back. Thanks.